Alright, let's say we're wanting to calculate either the price of a bond or its time or its yield to maturity. Now, with bonds, a typical bond has a face value of $1,000. Okay, of course, bonds are traded, every day, so their market value may be different than their face value or the principal based on interest rates. So they pay a stated coupon interest rate that does not change. Typically they pay them every 6 months, and they have a set time to maturity, 5, 10, 20 years, whatever the case may be. So we're going to do a couple of examples to show you how to calculate either the price of a bond or its yield to maturity. First, we'll do a price. Let's say we have a 20-year bond that has a 6% yield to maturity, so that's the market rate for similar bonds. That's what they are returning. An 8% coupon and $1,000 face value, and we want to know the price. Right? Now, I will first do it as if the bond pays its interest annually, and then we'll adjust it to be more realistic with semi-annual payments. So it's a 20-year bond, so we're going to use our 5 time value of money buttons on our Texas Instruments BA2 Plus. We hit 20 for in. Now we always put the yield to maturity in the interest rate, not the coupon rate. So our yield to maturity on this bond was 6%, so 6 and IY. Remember, we always put interest rates in as whole numbers. Now it says it pays a coupon of 8%. So what we have to do is take that coupon rate times the par value or face value of $1,000 to see how much interest this bond will pay every year. So 8% times 1,000 is $80. So we hit 80 in the payment. Okay, so we put the dollar amount in the payment. We don't put the 8% in there. And then we hit for the future value, the bond when it matures will pay back its face value of $1,000. So we hit 1,000 future value. And then we want to know its price. So we hit CPT, compute, and then PV, present value. And you can see this bond will currently sell for $1,229.40 if we round. Now again, ignore the negative. The calculator looks at cash flows as cash inflows and outflows, so you can ignore the negative. All right. Now let's say, what if this bond paid semi-annual interest instead of annual interest? All right. So let's hit second, clear time value of money, so second future value, to clear out our buttons, and we can enter this in again. So if it pays semi-annual interest, what we're going to have to do is multiply the number of years times 2, divide the yield to maturity by 2, and divide the coupon rate by 2 to calculate a correct payment. So it's a 20-year bond, but since it pays interest semi-annually, 20 times 2 is 40. So we hit 40 and then the N. On the interest rate, it was a 6% yield to maturity divided by 2. So you get a semi-annual rate, so 3 IY. It's 8% coupon divided by 2, so 4% times the $1,000 par value. $40 is how much the bond will pay in interest every 6 months. So 40 and then PMT. And again, 1,000 is our face value, so we don't have to adjust that. Just put 1,000 future value, and then we hit compute present value to see with semi-annual compounding this bond is worth $1,231.15, slightly higher than what it was with annual compounding. All right, so we'll hit the clear. We'll hit the second time value of money again. Now let's say if we know the price of the bond, but we want to figure out what that return or yield to maturity will be based on that price. So here's another example. We've got a 10-year bond, a 7% coupon rate. Its current price is $1,050, and its face value is $1,000. All right. So again, we'll do annual compounding, and then we'll switch to semi-annual. So with annual compounding annual payments. So 10 in. Of course, we're solving for our interest rate, so we'll have to leave that for last. Our present value is $1,050. So that's how much the price is of the bond is right now. Now remember, when you're putting in both present value and future value, you have to make one negative. So make the present value negative. So hit plus minus and then PV. The coupon on this bond is 7%. So 7% times 1,000 is $70. So 70 goes in payment. And then the future value is again the bond's par value of $1,000. So 1,000 future value. And then we hit compute and the interest rate. And you can see the yield to maturity on this bond is 6.31. Now we knew that it would be less than 7% since this bond is selling at a premium. It's selling for more than $1,000. And that's a relationship that you need to remember, is that when a bond's coupon rate is higher than its yield to maturity, it will sell at a premium. When the bond's coupon rate is equal to yield to maturity, it will sell for its face value. And when the bond's coupon rate is less than its yield to maturity, it will sell at a discount, something less than its face value. All right, so that was 6.31. Now let's adjust our example to be semi-annual compounding. So again, the 10-year bond, if it's semi-annual, you multiply by 2, so it's 20 periods. So 20 is your in. Its coupon rate is 7%, but it's semi-annual. So 7 divided by 2 is 3.5 times 1,000 is $35. So 35 payment. Now notice that, remember, I did not clear the time value of money buttons out this time. Since the price, we don't adjust the price, or the face value, we can leave those in there. Right? So the price is $1,050, the face value is 1,000. So then we can just hit compute the interest rate, and you get 3.159. Now notice that is a semi-annual rate, but interest rates are always quoted in annual percentages. So to compare that to our prior example, we multiply that by 2 to get into the annual rate of 6.3179, which is again slightly higher than what we had previously. I think that's all that we can do with bonds, or all we're going to do right now. So I hope this helps.